A warm welcome to all. Today we are going to talk about another important topic, which is called conjugate acids and bases in human body. My name is Anu Sharma. Now, in the last two classes we talked about acids and bases. We defined acids as substances which donates the hydrogen ion, and also we define bases as substances which accepts the hydrogen ion. You can go back to my earlier classes to have the concepts of acids and bases. Now, so what is a conjugate acid? The definition is a conjugate acid is a chemical compound which donates a proton to a base. So it is firstly a chemical compound, and this compound donates the proton to a base, or in other words, it is a base with a hydrogen ion added to it. Okay, so chemical compound, this chemical donates a proton to a base or a base with a hydrogen ion added to it. And what is a conjugate base? A conjugate base is again a chemical compound that remains after an acid has donated its proton. So after acid has donated its proton, the compound that remains is the conjugate base. So what is the criteria for conjugate acids and bases? So they should have the same molecular formula. Number one, they should have the same molecular formula, but they should differ only by the presence or absence of a single hydrogen ion. So by the presence or absence of a single hydrogen ion, and they should have the same molecular formula. So let us look at some examples. What happens when acetic acid reacts with water? So this acetic acid, this reacts with water to form hydronium ion and acetate ion. So this acetic acid is a weak acid. I have also talked about strong and weak acids in my last classes. You can also look back at my classes. So in short, a weak acid is one which does not completely dissociate into its products, and this reaction is biodirectional. There is a forward reaction and a backward reaction. So let us break this reaction. In the first step, this acetic acid donates the hydrogen ion to water. So according to definition, an acid is a substance which donates the hydrogen ion. So because acetic acid has donated the substance to water, it becomes an acid, and the water, because it accepted the hydrogen ion, it becomes a base. In the second step, what happens? Now it goes to backward reaction. Now the hydronium ion H3O, it donates the hydrogen ion to water. So now this becomes an acid and this becomes a base, and this acetate ion now accepts this hydrogen ion to form acetic acid. Now this is an acid and now this becomes a base. So in the final analysis, what we find, this acetic acid becomes an acid, and what is its conjugate base? Acetate ion. And this water is a base. What is this conjugate acid? Is the hydronium ion. Look very closely. To get the conjugate base from the acid, just remove this hydrogen ion. Or to get the conjugate base from the acid, you just have to add the hydrogen ion. Okay. Secondly, you find that there is a positive charge and negative charge. Once this acid donates this hydrogen, so there becomes a negative charge, and once it releases accepts hydrogen ion, it becomes a positive charge. Let us take a second example. Hydrofluoric acid reacts with water to form hydronium ion and fluoride ion. This again is a weak acid because the reaction is bidirectional. So in the first step, what you find is hydrofluoric acid reacts with water. Now the hydrogen of the hydrofluoric acid donates the hydrogen to water to form hydronium ion. So this hydronium ion, now because the hydrofluoric acid has donated the hydrogen, it becomes an acid, and the water accepts the hydrogen, so it becomes a base. The second part of the reaction is that now you see the fluoride ion now accepts the hydrogen ion to form the hydrofluoric acid. Now this becomes a base, whereas the hydronium ion, now what happens is that it releases the hydrogen ion to form water. So now this becomes acid. In the final analysis, what you find, that hydrofluoric acid is an acid, and what is this conjugate base? Is a fluoride ion. Water is the base. What is the conjugate acid? Is the hydronium ion. So to get again the conjugate base from the acid, you just remove the hydrogen ion from the acid, and to get the conjugate base from the acid, you just remove one hydrogen ion. Remember, always one hydrogen ion. You're adding or removing this one. Third example, let us look at ammonia. Ammonia reacts with water to form ammonium and hydroxyl ion. Now, this reaction is again a weak acid, is bidirectional. Now, in the first step, The water, now look at the opposite side, water gives one hydrogen ion to the ammonia. So now because water has given hydrogen ion, now it becomes an acid, and now ammonia has accepted hydrogen, now it becomes a base. In the second reaction, when you look at a backward reaction, the ammonium now releases one hydrogen ion to hydroxyl ion. Now because it's given one hydrogen, it becomes an acid, and because the hydroxyl ion has accepted one hydrogen, it becomes a base. So in both the reactions, what happens is that this ammonia becomes a base, and what is the conjugate acid? Is the ammonium. And this water is an acid. What is the conjugate base? Is hydroxyl ion. So this is the third example we talked about. What about water? Now water, if water reacts with water, it forms hydronium ion and hydroxyl ion. Now it can act both as an acid and base. How? Now from this first reaction, water, it gives one hydrogen ion to form hydroxyl ion. So this water acts as an acid, and this becomes a base. Now on the reverse reaction, the hydronium ion now gives rise to loses one hydrogen ion to form water. So now this becomes an acid, and then becomes a base. So a substance which acts both as an acid and base, as in water, is called an amphoteric substance. Lastly, what about this hydronium ion? If hydronium ion dissociates hydroxyl, can we consider it as a conjugate acid base pair? No, because once it dissociates hydroxyl, it loses two hydrogen ion. You see this tree is one. According to the definition of conjugate, it should be differing by only a single hydrogen ion proton. So this cannot be a conjugate acid base pair. So what is the importance of conjugate acid base pair in the human body? So the importance lies in conjugate acid base is in the buffer system, because conjugate acid base plays a very important role as a buffer system in the human body. So what is a buffer? A buffer is a solution, usually a weak acid, which resists the change in pH when an acid or base is added to it. So a buffer is a solution. So what that means that when acid or base is added, the solution containing vapor pH of the solution will never change. So if you add an acid or base buffer solution, the pH will not change. So let us look at some of the most important buffers in our human body with conjugate acid base pair. The most important buffer system in a human body, which plays an important role in regulation of pH, is the bicarbonate buffer system, which is present in the blood. Now look at this bicarbonate. This is the carbonic acid. It's a weak acid. It dissociates into hydrogen ion and the bicarbonate. Now what is the conjugate acid of this carbonic acid? It's a carbonic acid because it has lost one hydrogen ion, it becomes a carbonic acid. So carbonic acid, the conjugate base is the bicarbonate. So this is a conjugate acid, and this becomes a conjugate base. Let's look at the second buffer, which is very important. It's a hemoglobin buffer. So this again present in blood. Hemoglobin, it has got a lot of histidine residues. So this histidine residues, when it dissociates, it gives us a histidine and a hydrogen ion. Now this histidine with hydrogen, when it lost one hydrogen, now this becomes an acid, and because it has become a single histidine, it becomes a base. And the third important buffer is a biphosphate buffer system, which is present inside the cells. This is a dihydrogen phosphate. This gives rise to hydrogen phosphate. Now this becomes an acid because it has lost one hydrogen ion. See, from this H2 it becomes 1. So this becomes an acid, and because it has lost one hydrogen, this becomes the conjugate base of this biphosphate. So it is in short about conjugate acid base pairs in the human body. The importance lies in the buffer system, which we will talk in the subsequent lectures. Buffer system helps us to regulate the pH against all extremes of our body metabolism. So I hope that you have really learned something about this lecture. Please do subscribe to my channel and give a thumbs up to my talks and all. This will help me in motivating further talks. Till then, take care. Goodbye.